Hello students, today we will talk about feature selection. So what are essentially features? So we've been looking at examples and let's see this site UCI repository. So suppose I'm talking about a data set which has apartment for rent classified data set. Now these are the attributes which I have. So I have 22 attributes and I have 10,000 instances of this particular data set. So here the attribute information is given to me and I'm trying to find out the cost of an apartment based on the attributes given to me. So here I would have my features x1, x2. So suppose I have 22 features, then I would have an instance of each and every attribute and I have 10,000 such instances. So all my rows that I have, these are vectors and each column is a dimension. So each column is also known as a feature here. So in this lecture, we will try and explore as to how we select the best features for our modeling. And in case we have a large number of features, then we will also try and understand how to reduce the number of features. So let's first look at the uses of features. So features may be used to split. So I may be splitting my entire data set using my number of features that I have. So here you can see, if you look at the same repository here, I can have univariate where I have a single data available with me. So these would be basically like a time series kind of a data set where maybe I just have price of a share over a period of time. So it's a univariate kind of a data set. I could have univariate, I could have bivariate where I have two variables, and I could have multivariate where I have more than two features available. Then I could have binary. So binary means I am able to split my data set into two parts. So this kind of a data set where I have two classes available with me. So it's a binary data set. We are trying to predict whether a person makes over 50,000 a year or not. So this is a prediction task and it has two outputs, yes or a no. So it's a binary kind of a data set here. Non-binary, when I have more than two classes, so we discussed the iris data set which has basically three classes. So you can have n number of data sets here. So you can explore this site and see as to how these data sets are to be able to understand them better. Similarly, I could be using these features to predict. So in the regression cases, I am trying to predict maybe the price of a flat, then it's used to predict, right? So these are the uses of features. Now how do we construct features and how do we transform them? Now there are various operations that I can do on features. I can construct new features. So how do I construct new features? Suppose I have a data set which has information about employees such as their years of experience, their annual salary and the number of hours they work per week. Now to be able to construct a new feature, what I could do is I could represent hourly wage of the employee and I could calculate this by dividing the annual salary by the number of hours worked per week and the number of weeks in a year. So then I will have an hourly wage of the employee, which is a new feature and it is constructed from the values already present with me, the features which I already have. Now how is this new feature important? So this new feature could help the HR department to provide a clearer representation of the compensation received by the employees for each hour worked. So you could find out from this feature, you could compare the hourly wages of employees across different departments. You could also identify employees who are underpaid compared to the employees with similar years of experience. So this new feature is constructed using the existing features and it is useful for me in different ways. Then I could do feature transformation. So transformation could be very simple transformations like converting a temperature value into categories such as cold, pleasant, hot. So I am talking about the temperature of a day. So I could say any temperature less than 14 is cold, between 14 and 30 is pleasant, anything above 30 is hot. So I am basically transforming my feature into some categorical variable and this is a feature transformation. Feature selection. So I could select features based on their importance. And where is this useful? It is used in high dimensional data such as genomic DNA and text documents where I have number of attributes available with me and I want lesser features to be able to proceed to the next step of modeling. So what are the methods that I have? So I will discuss each and every method here that we have seen. So in the univariate analysis, we look at one feature at one time and I look at the analysis with the other features. And in multivariate, what I do is I consider all the features simultaneously. So let's first start with the univariate. So the idea behind feature selection is that we rank the features by their importance, and then there's a certain cutoff which is determined by us. Then we are able to select those features for further modeling. So let's first look at the Pearson correlation coefficient. So correlation is basically when you try and plot. So suppose I have two attributes x1, x2, and I have certain values. What do? I take a scatter plot and I plot these two values. So maybe if they are highly correlated, I will have something like this. So there's a positive kind of a relationship. If x1 is increasing, x2 is also increasing. I could have a negative correlation, something like this, where one is increasing, the other is decreasing. I could have, so these are the kind of values that I could have. This is perfectly -1, where they are completely opposite to each other. So y is equal to -x kind of a relationship. Then I have something scattered like this. So it's a relationship definitely, but it is a negative relationship. I could have a positive relationship. So this seems to be perfectly aligned, x is equal to y. And this is some kind of a correlation, a positive correlation, and these seem to be uncorrelated. So a correlation can be mathematically found out by finding out these values here. So in data science, we already cover this correlation coefficient in detail, so I will not go through it again. And here you're just trying to find out the correlation between two variables. Now when it comes to feature selection, what do? So if there's a high positive correlation between two features, then I know that there's a dependence between these two features, and taking both of these features into my modeling is not good because both of them are kind of dependent on each other. So that is why what we do is we take one of them, retain one of them and remove the other one. In other case, what we do is we find out the correlation between each feature with the target variable. So here what we are saying is find out the correlation coefficient between each feature. So between each feature and the target variable, and then keep features with high absolute correlation values. If I am seeing a high correlation between these two, the target variable and this variable, then I will retain this. Similarly, for each and every feature, I will try and find out the correlation between the target variable and that variable and retain it if it is a high correlation value. Then we move on to the one-way ANOVA. So what is this is basically analysis of variance, which we again covered in depth in the data science course. But I'll just to recap, it is a statistical test used to compare the means of two or more groups. When it comes to the context of feature selection, how does it help us? So ANOVA can be used to identify features that are most important for giving prediction tasks by comparing the mean prediction performance of a model with or without each feature. So what are we doing? Suppose I have lots of values here, x2, x3 and so on, and we have a target. What we do is we eliminate this and we find out the performance of this model. Then in the next step we will include this but exclude this, and then again find out the performance. So the basic idea is to train a model on a data set with one feature excluded and then compare the model performance to the model trained on the complete data set. If the performance of the model with the feature excluded is significantly worse, so it's got worse than what it was with all the features, then that feature is actually important because after removing it, my performance is decreasing. So that is why I will retain that particular feature. This process is repeated with each and every feature, and wherever the performance decreases, I will take that feature into account, and then finally for my modeling I will use the features which are important. And this will help my feature reduction without sacrificing the accuracy of the model. Now a small example, so maybe I have some student performance value and I have lots of data for a student with me, like I have the age, the guardian has some points associated in whatever way they are calculating, maybe their education or maybe their employment, whatever, the study time of the student, the failures, the activities he is doing, a lot of data. Now what we want to do is we want to find out whether the contribution of the parents is there in his performance or not. So what we will do is we will do the analysis of the entire performance with these features and without these features, and if there is a significant change, we are trying to find out the variation in the performance by removing certain features, and if the variation comes high, if the performance you feel is affecting after removing the guardian's information, then that information is significant. So that is how we find out the importance of features. Now then there's another method called the F-score. So F-score is basically, it is found by this particular formula here. I will not get into the details again because this is covered in the data science part. But just to recap, so F-score is a commonly used measure in feature selection to assess the importance of the feature in a data set. It is based on the ratio of calculation of mean of feature to the variance of feature. So you can see here we are trying to find out the ratio between, so here you have the variance and here you have the mean value. So here we are trying to find out the ratio between these, and this gives me the F-score. Now generally F-score is not used separately. It is used in conjunction with other statistical tests like one-way ANOVA and all. And the idea is to calculate the F-score for each and every feature and then rank the features based on their scores. So what we do is we find out this F-score and then we rank the features. The higher the F-score, the better the rank of the feature is, and we will consider it more important. So higher the F-score are considered more important and we include them in the final feature set. So you have inbuilt functions for this. You could just say that I want 4 features, so it will give me the top 4 features, and based on this I will have this feature selected, then this feature, and this. So the top 4 features will be selected and I could use them for my further modeling. Now the chi-square test. So again the details we will not cover because it is a part of data science course, but to recapitulate in a sense of the feature selection, chi-square test is used for categorical variables. So till now we were talking about numerical variables. Now we have a categorical variable, quantitative and qualitative. So here the category is defined. So it is a similar test to ANOVA, but it is for categorical variables. So what are we doing? We measure the dependence of 2 categorical variables by comparing the observed frequencies of a variable in different categories with the expected frequency under the assumption of independence. Now features that have higher significant relationship with the target variable according to the chi-square test are likely to be important. So it's a similar kind of a test. Just like ANOVA, here we are doing it for categorical variables, and if my relationship is significant, I will have a higher score value here, and if I have a lower score value, it means it is not significantly related to the target variable and we can remove this from the model. It is not applicable for continuous or numerical variables because we use ANOVA over there or correlation over there. Then we come to this SNR, which is the signal to noise ratio, which we study in electronics. So signal to noise ratio is a metric which is used for assessing the quality of a feature. So it is not talking about your target variable here, it is just simply talking about the quality of your feature. So what we are trying to find out is the difference between the feature values in the target class. So my signal is what? It is the difference between the feature values in the target class, while the noise refers to the difference between the feature values within each class. So we are talking about each and every class we find out. So there is an intra-class and inter-class kind of a division. When we are talking about the target class differences, then we talk about the signal part, and for the same within each class, then it is a noise part. A high SNR value indicates that the feature has a large difference between the target class and the non-target class, and therefore it is a good predictor. So that is why we will include it. But we need to remember that it is a very simple measure which may not capture all aspects of the relationship between features and the target variable. Therefore, it is recommended to use multiple feature selection techniques rather than just depending on this. We need to be sure, we need to reiterate with the other selection techniques to be able to remove a certain feature based on SNR. Now we move on to the multivariate. So we were talking about, so here we were talking about univariate analysis. Now we talk about multivariate, where I am looking at all the features simultaneously. So we will just talk about PCA here. PCA is the principal component analysis, which I had talked about in the previous lectures also. It is a dimensionality reduction technique. So suppose I have 1000 features here, right? So x1 to x999, 1000. So I have all these features present with me and I want to make a model. So if I try and model all the features together, it's going to be a very, very complicated model. So I need to probably find out lesser number of features here. So suppose I want just 5 features out of this. So what will I do? I will use PCA. So PC essentially what it does is it forms a new set of linearly uncorrelated components. Uncorrelated means that if I find out the correlation, so I may have one PC1 which is actually x1 plus 2x2 plus 4x10 plus whatever, some linear function of x100 plus whatever, some kind of a combination here. My PC2 may be some other feature which it finds out automatically based on some eigenvalues. So it may have x3 plus whatever here, and these are uncorrelated. If I find out the correlation between them, it will be close to 0. So it is finding linearly uncorrelated components, and these are known as the principal components here. These components capture the most important information of the original features and often result in reduced number of components that still retain most of the information. Not all, but most of the information is retained. So I am able to reduce the number of features significantly and I am still able to retain my information here. PCA can be used to identify the principal components that explain the majority of the variance. So my variance of the data is majorly explained by these new principal components that I get. Features that are strongly correlated with the principal components are likely to be important for prediction and should be kept. On the other hand, weakly correlated are removed. And here also you have to remember that we do not take into account the target variable. So here also we need to use PC in the combination with other feature selection techniques before removing any features. So there are lots of feature selection in practice. There are lots of competitions here. You can go through the NIPS 2003 feature selection contest and study more in case this interests you. So this brings us to the end of this class. I will continue in the next one. Thank you.